All right, let's dive into a classic networking puzzle. It's all about how you can build in reliability with backup paths without accidentally bringing your whole system to a crashing halt. We're going to look at the two key protocols designed to solve this: the original Spanning Tree Protocol, or STP, and its much, much faster successor, RSTP. Okay, think about this for a second. What if adding a backup cable, the very thing you plug in for safety, could actually trigger a total network meltdown? It sounds completely wrong, doesn't it? But this is a real fundamental problem in local networks, what we call Layer 2, and understanding the fix is absolutely critical. You know, having a backup plan is always a good idea, right? In networks, we call that redundancy, having more than one way to get from point A to point B. And that's great. It means if one connection fails, traffic can just find another way. But this creates a really dangerous side effect: network loops. When data can just circle around endlessly with no exit, things get very bad very fast. So what does this very bad, very fast actually look like? Well, it's called a broadcast storm, and it is just as chaotic as it sounds. It all starts with one single broadcast message, something totally normal. But in a looped network, the switches just keep forwarding that same message over and over. That one message gets duplicated, then those duplicates get duplicated, and in seconds, you have an insane storm of traffic that eats up all your bandwidth and basically suffocates the network. So, to prevent this absolute chaos, back in 1985, some very smart engineers came up with a hero for our story: the Spanning Tree Protocol, or STP. Its whole job, its entire reason for existing, is to stop these loops before they can even start by creating one clean, logical path for data, even when a bunch of physical cables are plugged in. So how does this Guardian actually do its thing? Well, it's pretty clever. First, all the switches on the network basically hold an election. They pick one switch to be the boss, the root bridge. Think of it as the network's North Star. Then, every other switch figures out the absolute best, fastest path to get to that root bridge. And what about all the other extra redundant paths? Well, STP just puts them to sleep. It logically blocks them so they can't cause a loop. But, and this is a big but, our hero had a fatal flaw. What happens when that main path actually fails? You know, a cable gets unplugged or a switch dies. Well, that backup path needs to wake up and take over, right? The problem is, it takes STP a long time to do that. We're talking 30 to 50 seconds. That's its convergence time. And you know as well as I do, in today's world, 30, 50 seconds, that's an eternity. That's not just an annoyance. That's a video call with your boss dropping right in the middle. It's an online purchase failing at checkout. It's productivity grinding to a halt. It's just not gonna fly. So this is where the sequel comes in, the faster, stronger hero. Enter Rapid Spanning Tree Protocol, or RSTP. As the name suggests, it was designed for one thing and one thing only: speed. It does the same job as STP, but it does it way, way faster. So what's its secret? How is it so much faster? Well, RSTP is smarter. It adds these new port roles called alternate and backup. Think of these ports as being on standby, like a runner in the starting blocks, just waiting for the signal. They've already figured out where they need to go if the main path fails. So instead of a long recalculation process, they can just go, almost instantly. And the difference is just staggering. We go from 30 to 50 seconds of downtime with STP all the way down to just 1 to 3 seconds with RSTP, sometimes even faster. That's not just an improvement, it's a complete game changer. So, one big reason RSTP is so quick on its feet is that it simplifies things. The original STP had this whole 5-step process for a port to become active: blocking, listening, learning. It was a whole ordeal. RSTP just cuts through the red tape. It combines a bunch of those into one simple discarding state: less talk, more action. And this goes hand in hand with those smarter port roles we mentioned. STP was kind of basic. You had your root port, your designated port, and everything else was just blocked. RSTP gets more granular. It adds those alternate and backup roles. That's the key. It knows what the backup plan is ahead of time, which is why it can react so fast. Okay, so when you put it all together side by side, the picture becomes crystal clear. RSTP beats the original STP in every single category. Convergence time, way faster. Port states, simpler. Port roles, smarter. It just handles changes better and scales way better for the kinds of networks we all have today. So this probably has you wondering, right? If RSTP is so much better, why would anyone ever Still use the old STP? And believe it or not, there are a couple of reasons, but they're pretty much all about old school gear. The main one is if you have ancient network equipment that just doesn't know what RSTP is. And because RSTP is designed to be backward compatible, if it sees an old STP-only device, it'll actually slow itself down and revert to the old STP protocol just to be able to talk to it. But let's not get it twisted. That's a compatibility thing, not a choice you'd want to make. The final word on this is simple. If your network gear can run RSTP, and pretty much anything made in the last decade or two can, you should absolutely be using it. It's just better, more efficient, way faster recovery. It's the modern standard for a reason. So, look, moving from STP to RSTP was a huge leap. It fixed a massive problem with network recovery time. But that's how technology always works, right? You solve one bottleneck and it just reveals the next one in line. It makes you wonder, now that our networks can recover in a second or two, what's the next big problem we need to solve? What's the next bottleneck? Something to think about. Thanks for joining me.